Hello, this is Rocky, and this is my video demonstration for design assignment 2A, in which there are two tasks. Right now we're looking at task 1. We can see in our Solution Explorer, I stored our assembly code and the C code into one area. And right now we're looking at the assembly coding for task 1, in which in this task, we want to toggle an LED on and off with a square wave in which 60% duty cycle is high and 40% duty cycle is low, with a period of 735 milliseconds. And so we could see I have the main function which toggles between LED on and off. And I use delay subroutines, in which I actually wrote the code for the delay subroutines, which are two different ones that use nested loops. And I also use NOP instructions to contribute to the delay. And also keep in mind that we are able to change the size of the delay by changing the values of the registers to determine the instruction counts or executions. And so I'm going to go ahead and run this code. We can see that it assembles the code without any errors. It runs smooth. And so if I look at the actual board, I'm using a shield in which the reason why I connected a green LED on the board is because on the explain mini is because the shield, the LED is connected to high automatically, and I wanted to generate a square wave with a 60% duty cycle high. And so technically on the shield it's 60% of the time is low, 40% of the time is high, and then the LED connected to the explain mini is in its original state, in which it's 60% duty cycle is high and then 40% duty cycle is low. So we could see the two alternate even though it's the same output signal. And so looking into seeing how this code operates with the C version of the coding, which is a lot more shorter. We use a while loop, and we make sure that we set the direction of the pin correctly, and we just use the delay function provided with in the C coding delay library. And then I multiplied the milliseconds by 16 because it's a 16 megahertz oscillation on the explain mini. And so I am going to run this code, in which we can see that it compiles without errors, it runs smoothly, and then looking at the explain mini, it operates with the same functionality, in which the green LED 60% of the time it's high, 40% of the time is low, and then the LED on the shield is 60% of the time it's low, 40% of the time it's high. So we see the two alternate, and that basically shows the task 1 for the assembly and C coding. So I'm gonna stop running this code. Oh, I forgot to set this as a project. Okay, I'm gonna set that as a startup project, and I'm gonna recompile it again, just to make sure that it looks nice and it still operates the same. So I forgot to set that as a project, so it didn't compile that correctly, but now it did, and we can see that it's the same thing. So that's the C coding. I'm gonna stop that, and yeah, we're on the C file, so this is correct. So I'm going to open task 2, in which I stored it into a different file, and I did the same setup in which I have the assembly and the C file in one area. So I'm going to look at the I'm going to set up the assembly file as a startup project, and then looking at the assembly coding. It follows similarly as the previous task, in which I used the same delay setup, except I changed the value of the registers to obtain a delay of of 1.25 seconds. And so I'm also taking into consideration we're using a pin C to read a value. And so our main function, I have a check right here, which basically checks to see whether the pin is read as a high, and when it is read as a high, it outputs the LED for 1.25 seconds before going low again, and then it recycles, and it loops, I guess. So if I go ahead and compile this code, this assembly, or assemble this code rather, no errors, we could see it assembles appropriately. And looking at the board again, as mentioned, the LED is automatically on because it's pulled high on the shield, and then the green LED is connected to the actual explain meanie, where the source output is low. If I toggle the switch, which is, by the way, high, so I had to edit the code to compensate for its high to toggle correctly. I'm going to go ahead and click the switch, in which I expect this red LED to go low for 1.25 seconds and the original green LED on the explain meanie to be high for 1.25 seconds before going back to its original state. So I'm going to click it once rather quick, let go, and yeah, 1.25 seconds. I'm going to do it again, 1.25 seconds. If I hold it, it's just going to continue to execute the same 1.25 seconds longer until I let go. So yeah. And let's go ahead and see how it works with the C coding. So this was the assembly code once again. I'm going to set up the C coding as a startup project. And so now I have it bold. And then looking at the main C coding. The C coding is fairly short compared to the assembly code. I use defined statements to make it easier to read for the LED and switch, which are both the same bits, just different pin or port. And so I use an if statement to check when the switch is high or low rather, since the switch is already pulled up to high on the shield. So I check for the switch being pressed, and then when it's a high, I output the LED for 1.25 seconds. So same function. I'm gonna run and compile this. We could see that it runs smoothly, no errors. Looking at the shield, as mentioned, the LED is already on, and then the green LED is on the explain meanie is low. I'm gonna click this, and it performs the same task. If I hold it, and yeah, so that shows that the operation for the C coding works just the same. And that concludes my video demonstration for design assignment 2A, and I will be posting pictures of the waveforms on the logic analyzer, which will be posted as photos in the actual assignment. Thank you for watching.